known as relative frequency, or in brackets there you can see experimental probability. And this is where we base the answers on what's gone on before. So my question to you is, if Jack Crowley scored 4 kicks out of 5, what is the relative frequency that he will score his next kick? Well, based on what he's already done, he's got 4 out of 5, so he's an 80% chance of scoring his next kick. No, but yeah, now it depends, right? So theoretical probability would say, now, it's not 50-50, because a kicker, you'd have a higher chance of scoring. If you were flicking a coin or something, theoretical probability states things like the 50-50. This is the difference. Relative frequency is based on the data that's already captured. Let's say Cristiano Ronaldo scored 90 penalties out of 100. So that's 9 out of 10, isn't it? Now, based on the relative frequency, what chance does he have of scoring his next penalty? He's a 9 out of 10 chance. So relative frequency is all based on the experiments that are carried out. It's not theoretical probability, like, oh, what's the probability of getting ahead if I flick the coin? It's 50-50. But let's say I flicked that coin 100 times and 96 of them were heads and 4 of them were tails. What does that indicate about that coin? It's some sort of fake, and it's biased towards heads. So, relative frequency is an estimate of the probability of an event. It's an estimate. So if there are a large number of trials, if there are a large number of trials, the relative frequency is a very good estimate of probability. So again, let's say Jack Crowley, he's taking kicks from the left-hand side of the goals, and he scores 77 out of 90 of them. Right? What is the relative frequency he scored at his next kick? 77 out of 90. It's based on the probability of the trials that are already carried out. So, relative frequency is the number of times the event happens in a trial over the total number of trials. Again, Crowley there, I said to you, 90 kicks he took, scored 77 of them, it'll be 77 out of 90. Right? So it's based on the data. So here's the question. An experiment is conducted to show the number of trials, how the number of trials improves the accuracy of the relative frequency. So Michelle flips a coin and records her results every 10 flips. Watch this. So after the first 10 flips, she got 6 heads and 4 tails. So what is the relative frequency of getting a head? It's 6 out of 10, isn't it? Which is 60%, or 0.6 in decimal. What is the relative frequency of getting a tail? It's 4 out of 10, or 0.4, 40%. Now, relative frequency is usually given in decimal form. Usually. Right? So we move it on now. She fixed it another 10 times on top of the 10 that she's already done. Right? So she's done another 10. So now we're up to 20 flips. Now she has 13 heads and 7 tails. So the relative frequency at this stage would be 13 out of 20 of heads and 7 out of 20 of tails. Yeah? Remember, it's based on the data. Now we go to 30 flips. Now we're recording all the data. What's gone on and what's next to 10 flips, she's up to 30. Now we've 13 heads. Geez, what happened there? Out of the next 10 flips, she used 10 tails in a row. Didn't she? So now the relative frequency out of the 30 flips, 13 out of 30 for heads, 17 out of 30 for tails. What's 17 plus 13? 30 out of 30. You're either going to get a head or a tail. Moving up to 40 flips. She's now on 18 heads and 22 tails. Now, again, the theoretical probability of flicking a head or a tail should be 50%, shouldn't it? So 18 out of 40, is that close to 50%? Not far away, 20 out of 40. Then we've got our tails, 22 out of 40. And the last one, oh my God, heads, 24 out of 50. Tails is 26 out of 50. Aren't they both very close to 50%? Or 0.5? Aren't they? So now, draw on this. The tails results are plotted. After 10 flips, 0.4. After 20 flips, 0.35. After 30 flips, up to 0.57. After 40 flips, 0.55. 50 flips, 0.52. So, and that is relative frequency. So the actual probability, we would expect 50%. So it wasn't too far away, and I guarantee you, if you did more trials, it would get closer and closer to 0.5. The more trials you carry out. And that's a question that's often asked in probability. How would you improve the experiment? You carry out more trials. And the more the experiment is repeated, the closer the relative frequency is to the actual probability. And that is relative frequency.